Hey guys, how's it going? Today in this video I'm gonna go through this Leetcode 32 longest valid parentheses. So this is one of the top 100 like questions. So this question was asked by Amazon and for 11 times in the past 6 months and also other big techs. Let's dive in. As you can see, the question is not that difficult to understand. So we are given a string containing just the left parenthesis and also the right one. I find the length of the longest valid parenthesis substring. So example in here, this guy over here, the longest valid parenthesis substring is this guy over here, right? Um, because you have valid open, valid close, and that's it. And for this guy over here, the longest valid substring will be this guy over here in the middle, and take out this guy and this guy. Okay. And if we're given an empty string, just return as 0. And also we have some kind of string over here. And now I'm gonna solve this problem with big O of n for time complexity and big O of 1 for space. Basically, we just only need a few pointers here or there without using or we can solve it using a stack, but that takes a big of n for space, and we don't want that. We just want to go directly to the most optimal solution. And the code that I'm going to walk through with you has achieved the 95th percentile of all the solutions, so it's pretty efficient. Now I'm going to walk through the algorithm with you. So it is it's pretty clever solution, I must say. If you get it, it's not that difficult to understand, and also code wise, for the code, the amount of code is not that bad as well. So let's dive in. So first, we need to use the two counters. I call it left counter and also right counter. Basically, they count the number of left parentheses and the right parentheses that we encountered when we traverse through the string. And basically, we traverse the string 2 times, and we traverse from the left to the right for 1 time, and then from the right to the left, that's the second time. Okay, and first we start traversing from the left to the right, and I have this arrow here indicating the direction. For every left parenthesis we encountered, we increase the left counter by 1, and same for the right counter. For the right parenthesis, whenever we come across it, we will increase the right counter by 1. So now, whenever the left counter is the same as the right counter, basically what it's saying is when we have the equal number of left parentheses and the right parentheses, we will calculate. This is so. In this case, we have a valid. We have a valid parentheses. So for example, here in this case, we have the left counter equal to 2 and the right counter equal to 2 as well. Okay, so if we do that, we have to keep. So if in this case, we just calculate the length of the valid strings and also keep track of the max length that we have come across so far. And in the case when we go from the left to the right, when the right counter is greater than the left counter, so basically it is gonna be like this. When we go from the left to the right, so we have the right counter more than the left counter. So in this case, we have right counter of 2, right counter of 1, right? So in this case, we're gonna reset left counter and right counter, because no matter however we go further, so this is gonna be no use for us. Okay, and then that's it, and that's the algorithm. And that after that, so this is from the left to the right, and then now we traverse from the right to the left. The only thing that's changed is in here. When we from the right to the left, when we have the number of left counter more than the number of right counter, we reset, and that's the only twist. Okay, And yeah, so that is the algorithm. So feel free to pause the video here and code up yourself. And then I'm going to walk through the code with you right now. And first, we have the max length variable that keep track of the longest valid parentheses globally. And then as we mentioned, so we traverse 2 times from the left to the right and also to the right to the left. And I have some helper variables in here, left, right. So they are the left and right counters that we talked about. I initialize this as a 0, right? So for all the character in the strings, for when we come across a left parenthesis, we increase the left counter by 1. Else, that means we come across a right parenthesis, so we increase the right by 1. When we have the equal number for left and right, so we will update the max length. And in currently, so we will have compare the current max length with the current number of parentheses that we come across, which is the right brackets times 2, or you can use the left bracket times 2 as well. That makes no difference because now it's the left counter is the same as the right counter. And then when we traverse from the left to the right, when the right counter is greater than the left counter, so that's exactly this case. So from the left to the right, when the right counter is greater than the left counter, so this guy basically has no use for the future traversing. Okay, if that's the case, we just reset it. Okay, and as simple as that, and that's about it. And on the flip side, and we go from the right to the left. So on Python, we can be a little bit clever. We can just reverse the entire string by use the operation like this. So basically, we reverse the entire string for all the character for the reverse string. We do the same thing, and that's the only twist that we talked about, right? So when the right is less than the left, that's the flip side of this guy. So we reset it, and after that, we just return the max length. And that's it. And if we want, you can write a function to avoid some duplication. But I think now it's a bit more cleaner to talk about. That's why I'm going to leave it like this. So as I mentioned at the beginning, so space-wise, it's going to be big of 1. So because we have only this variable, helper variable, this guy and this guy over here. And for time complexity, it's going to be big over 2 n's, 3 n's in total. So 1 n, and 2 n, second n, this is for the for loop, and also this is reversing the string that takes a big O n as well. So it's big of 3n that boils down to big of n for time complexity. Yeah, so that's my solution to this problem. I hope you find this helpful. Thanks for